Hello everyone, welcome back to my YouTube channel. In this week's video, we are going to discuss 8 different questions that covers chapter 7. So let's get started. Question number 1. Decomposition of hydrogen peroxide into water and oxygen gas follows the first order reaction. In 50 minutes, the concentration of hydrogen peroxide decreases from 0.5 molar to 0.125 molar. Indicate the rate of oxygen formation when the concentration of hydrogen peroxide reaches 0.05 molar. In order for you to answer this question, the first thing you need to do is to write a balanced equation. So this is a decomposition reaction of hydrogen peroxide. So you need to write hydrogen peroxide, which will decompose into water and oxygen. So H2O plus oxygen. So let's check on the equation so that we can balance this out. So here we have 2 oxygen and here we have 3. So in order to make it 2, you need to put half over here. So half times 2 equivalent to 1. So 1 plus 1 equivalent to 2. So hydrogen, here you have 2 hydrogen and here you have 2 hydrogen. So this is a balanced equation. Alright, next up, we are going to see whether this is a first, second, or zero order reaction. So in the question, it stated that this is a first order reaction. So in a first order reaction, so the formula that we are going to use is ln AT is equivalent to negative KT plus ln A naught. Alright, so what are the information given to you? So it states here that in 50 minutes, the concentration of hydrogen peroxide decreases from 0.5 to 0.125. So from here, what we are going to calculate is the value of K. So now what we are going to do is we are going to plug in the value. So at first, the concentration is 0.5 and at the end, the concentration is 0.125. So ln AT means ln 0.125 negative K and T is 50 minutes. So we are just going to use as is plus ln A naught. So your initial concentration is 0.5. Therefore, from here you will get your K is equivalent to 1.3864 divided by 50. Therefore, you will get your K is equivalent to 0.0277. Alright, so in the question you were asked to calculate the rate of oxygen formation when the concentration of hydrogen peroxide is equivalent to 0.05. So the next thing that you need to do is you need to write the rate expression. So the rate expression of this reaction is equivalent to negative delta concentration of H2O2 over delta T equivalent to delta concentration of H2O over delta T equivalent to 2 delta concentration of O2 over delta T. Now you are going to compare between the oxygen formation and also hydrogen peroxide. So what we are going to do is we are just going to look at this and oxygen. Therefore, we can write the rate is equivalent to negative delta H2O2 over delta T is equivalent to 2 delta O2 delta T. Alright, so since you were asked to calculate the rate of oxygen formation, so what we are going to do is delta concentration of oxygen delta T is equivalent to what? So it's equivalent to, because these two, we're going to bring it down, so it's going to be 1 over 2 delta H2O2 over delta T. So bear in mind that this negative sign, you can just omit it for a while because it's just indicating whether this is at the reactant or at the product. So since we know that the rate of oxygen formation is actually equivalent to half delta concentration of H2O2 divided by delta T, so we can transpose this to rate. So we can write it as rate equivalent to half the rate constant times the concentration of H2O2, whereby the concentration of H2O2 is given in the question. So we are just going to substitute this with 0.05, and we are going to substitute this with the value of K, which is 0.0277, the calculation that we have just done before. So since we already know these two values, so we can find the rate of the formation of oxygen. Alright, so now we are going to transpose this into rate. So rate is equivalent to 1/2 rate constant times the concentration of H2O2. So given in the question, so the concentration of hydrogen peroxide reaches 0.05, and also your rate constant, which is the K, is equivalent to 0.0277. So now all we need to do is just plug in this value, 1/2 times 0.0277 times 0.05. Therefore, you will get 6.925 times 10 to the power of -1 molar per minute. So the concentration is in molar and the time will be in minute. So this is the final answer for the first question. Let's move on to question number 2. The rate of reaction for the reaction between ethyl acetate and the sodium hydroxide are as below. If the initial concentration for both reactant and the half-life are 0.01 molar and 16.1 minutes respectively, determine the time taken for the concentration of ethyl acetate to diminish to 5% of its initial concentration. Alright, so the first thing that we are going to tackle is the last statement, which is 5% of its initial concentration. So the initial concentration is 0.01, therefore 5% from 0.01 is equivalent to 5 times 10 to the power of -4 molar. So this is the final concentration. And then when you look closely at the question here, you can see that this is a second order reaction because this is 1 and this is 1, so 1 plus 1 is 2. Therefore, the half-life for second order reaction is equivalent to 1/K times the initial concentration. So from here, we know that your half-life is 16.1 minutes. Therefore, you can find the value of K because you were given the initial concentration 0.01 molar. Therefore, your rate constant for this second order reaction is equivalent to 1/0.161. Therefore, you will get your K is equivalent to 6.2112 molar per minute. Alright, so from this calculation, we already know what is the final concentration. And then we already know what is the rate constant. Therefore, we can use the formula for second order reaction to find what is the time taken for the concentration to diminish. So in other words, we can say 1/, concentration of AT, the final concentration, is equivalent to KT plus 1/A naught. Okay, so the final concentration is the one that we have calculated just now, is equivalent to 5 times 10 to the power of -4 and then the K is 6.2112. T is the one that we want to calculate, plus 1 over A naught. So A naught is given to you in the question, which is 0.01. So therefore you get your T is equivalent to 1900 divided by 6.2112. Therefore your T is equivalent to 305.8990 minutes. So this is the final answer for the second question. Question number 3. If the rate of formation of ammonia is 0.345 molar per second, what is the rate of disappearance of nitrogen gas? This is a rather straightforward question. The first thing that we need to look at is the equation, and given to you is a balance equation, so we just need to know that this part is the reactant and here is the product. So remember, at the reactant we need to have negative sign, and at the product we will have the positive sign. So we are going to write the rate expression. So rate is equivalent to negative delta concentration of N2 over delta T is equivalent to negative 1 over 3 delta concentration of H2 over delta T is equivalent to positive 1 over 2 delta concentration of NH3 over delta T. So now we need to check the question again. If the rate of formation of ammonia is this much, what is the rate of disappearance of your nitrogen gas? So what we are going to look at is just this one and also the ammonia. So now I'm just going to write it again. Negative delta N2 over delta T is equivalent to positive 1 over 2 delta NH3 over delta T. So given to you that the rate of formation of ammonia is equivalent to 0.345. Therefore, 1 over 2 times 0.345. So you will get the rate of disappearance of nitrogen gas is equivalent to negative 0.1725 molar per second. So this is the final answer for the third question. Question number 4. The half-life of a first order reaction is 32 seconds. What was the original concentration if after 2 minutes the reactant concentration is 0.062 molar? The most important information given to you in the question is that the half-life is 32 seconds and it is a first order reaction. So in a first order reaction, the half-life is equivalent to 0.693 divided by K. Therefore, your half-life is 32 seconds and you can find the value of K. So K is equivalent to 0.021656. So next up, because you know that this is a first order reaction, we can use the first order reaction formula, which is ln AT is equivalent to negative KT plus ln A naught. So from the question, you were asked to calculate the original concentration. When given to you is the final concentration, which is 0.062. Therefore, what we are going to do now is we are going to plug in this value. So ln 0.062 is equivalent to negative K, which is 0.021656 T. So what is your T? So now it's 2 minutes, but here you were given in seconds. So 1 minute 60 seconds. So 60 times 2 plus ln A naught. So you are going to find what is your A naught. So now all you need to do is you need to press your calculator, so you will get your A naught is equivalent to 0.18262. Therefore, you will get your A naught equivalent to 0.83308 molar. So this is the final answer for the fourth question. Let's move on to question number 5. Consider the following chemical reaction of rusting of iron nail. If the rate of disappearance of oxygen is 0.065 molar per second, infer the rate of disappearance of ferrum and the rate of formation of ferrum trioxide. So the first step to answer this question is to write the rate expression. So rate is equivalent to -1/4 delta concentration of ferrum over delta T is equivalent to -1/3 delta concentration of oxygen over delta T equivalent to +1/2 delta concentration of Fe2O3 over delta T. Given to you in the question, the rate of disappearance of oxygen is equivalent to 0.065. So what we are going to do is we are going to substitute this with the value. So we can write -1/4 delta Fe over delta T is equivalent to -1/3 times 0.065 is equivalent to +1/2 delta concentration of Fe2O3 divided by delta T. So this question can be divided into two. You were asked to infer the rate of disappearance of Fe and also the rate of formation of iron trioxide. So we are going to discuss on the rate of disappearance of Fe beforehand. So we are going to just look upon these values. So from here we know that -1/4 delta concentration of ferrum over delta T is equivalent to 0.0217. So if we were to find what is the rate of disappearance of ferrum, so delta Fe over delta T is equivalent to 0.0217 times 4. Therefore, it is equivalent to -0.0867 molar per second. So this is the first part. So we are going to do the rate of formation of iron trioxide. So for the rate of formation of iron trioxide, we are going to look upon these two. Therefore, from here we can get 1/2 concentration of Fe2O3 over delta T is equivalent to 0.0217. So when you want to find delta, Fe2O3 over delta T is equivalent to 0.0217 times 2. Therefore, the final answer for the rate of formation of iron trioxide is equivalent to 0.0434 molar per second. So this is the final answer for the 5th question. Let's move on to question number 6. Consider the reaction of formation of B from A. The rate of reaction is 1.6 times 10 to the power of -2 molar per second when the concentration of A is 0.35 molar. Calculate the rate constant given that the reaction follows the second order. This is a straightforward question whereby it states here that it follows the second order. So rate is equivalent to K, which is the rate constant, the concentration of the reactant to the power of 2 because it's a second order reaction. Given to you is the rate 1.6 times 10 to the power of -2 molar per second. And K is the one that you want to calculate, and your A, the concentration, is 0.35 molar. So since this is a second order reaction to the power of 2, therefore your K is equivalent to 1.6 times 10 to the power of -2 molar per second divided by 0.1225 molar. Therefore, you will get your K is equivalent to 0.130612 per second. So this is the final answer for the 6th question. Question number 7. The decomposition of dimethyl ether at 504 degrees Celsius is a first order with a half-life of 1570 seconds. Determine the concentration of dimethyl ether after 4710 seconds of decomposition. From the question, you were given the half-life of the reaction. So, and it follows the first order. Therefore, we can calculate what is the rate constant. So, the first order reaction, the half-life is equivalent to ln 2 divided by K. So, the half-life is 1570. So, ln 2 over K. Therefore, you will get your K is equivalent to 4.4149 times 10 to the power of negative 4. Alright, so since this follow the first order reaction, so we can use ln AT is equivalent to negative KT plus ln A naught. The question asks you to find the concentration of dimethyl ether after 4710 seconds of decomposition. Therefore, what we are going to do is we are going to assume your A naught is equivalent to 1. So your ln AT is equivalent to negative K, which is 4.4149 times 10 to the power of negative 4. And your T is 4710 seconds plus ln 1. Right? Therefore, you will get your ln AT is equivalent to negative 2.0794. Therefore, your concentration of AT should be equivalent to negative 2.0794. So, the final concentration shall be 0.1250 molar. So, this is the final answer for the 7th question. Alright, we are now at the final question for this week's video. The reaction between nitrogen gas and hydrogen gas will produce ammonia. If the rate of formation of ammonia is 0.345 molar per second, predict the rate of disappearance of hydrogen gas. Alright, so the first step to answer this question is to write the balance equation for this reaction. So the reaction is between nitrogen gas and also hydrogen gas. So nitrogen gas and hydrogen gas will produce ammonia. So we need to balance up this equation. So from here, you have 2 hydrogen and here you have 3 hydrogen. So if we times 2 here, so means that 6. So here we need to put 3. So here we have 2 nitrogen and here we have 2 nitrogen. So this is a balanced equation. So the next thing that we need to do is to write the rate expression. So the rate expression for this reaction is negative delta concentration of N2 over delta T is equivalent to 1 over 3 delta concentration of H2 over delta T equivalent to positive 1 over 2 delta concentration of NH3 over delta T. Given to you from the question, the rate of formation of ammonia is 0.345. So ammonia here is 0.345 and you were asked to predict the rate of disappearance of hydrogen. So we are going to look into these two only. Therefore, you can write negative 1 over 3 delta H2 over delta T is equivalent to positive 1 over 2 delta and H3 over delta T. So given to you here is equivalent to 0.345 molar per second. So it's equivalent to 1 over 2 times 0.345. So because you were asked to calculate the rate of disappearance of hydrogen gas, so you just want delta concentration of H2 over delta T. So this value you need to times 3. Times 3. Hence you will get 0.5175 molar per second. But since it's a disappearance of hydrogen gas, means the hydrogen gas is at the reactant. Therefore, your final answer should be negative. So this is the final answer for the 8th question. Alright, we have come to the end of this week's video. If you feel that this video is beneficial for you, please give it a thumbs up. So take care and be good. Goodbye.